Hello, and welcome to Pocket Science. In this video, we're going to be taking a scientific approach to breaking down one of the most fundamental aspects of the game Pokémon Pocket. It's something that you experience every single time you play the game, but you probably don't give any thought to. And that is, how exactly does your starting hand work? We know that you're guaranteed at least one basic Pokémon in your starting hand. You could run a deck with 19 trainer cards and one basic Pokemon, like the Mega Mawile EX decks that are running around right now, and you will always be guaranteed to start with that one basic Pokemon. Now, this is inherently different than how physical trading card games like the Pokemon trading card game works. They can't be programmed to guarantee you to start with that basic Pokemon, so they implement a mulligan rule. But since this is a digital trading card game we're talking about here with Pokemon Pocket, they are able to program the game to have you guaranteed to start with one or more basic Pokemon. But there are a number of different ways they could have done this, and the method that they chose has significant impact on how likely you are to start the game with a given card. And what's more is I've not found any definitive answers online explaining what method they used. So I decided to take a deep dive into this, and I'm going to share my results with you here. Let's take a look. Before we can get into the theories, I need to explain one decision I made in my experiment. And that is, I am playing a deck with exactly 4 basic Pokemon. This is because 4 is the number that best accentuates the differences between these 3 theories. Okay, with that aside, let's get into the theories. The first is the complete redraw rule. This is the closest rule to the physical Pokemon trading card game's mulligan rule. This is, you draw a hand of 5 cards naturally, just like normal, and then the game checks if you have any basic Pokemon. If you do not, which is about a 28% chance in a deck of 4 basic Pokemon, it will shuffle your deck again and draw you a hand of 5 new cards, and continue doing this until you get a legal hand of at least 1 basic Pokemon, and then that would be your starting hand. You obviously would not see all those potential reshuffles. That happens behind the scenes. In this theory, you have a 65% chance of having exactly 1 basic Pokemon in your hand. You have a 30% chance of having exactly 2 basic Pokemon in your hand. You have a 4% chance of having exactly 3 basic Pokemon in your hand. And you have less than a 1% chance of having all 4 basic Pokemon in your hand. The next theory is the pity rule. In this theory, you draw 4 cards like normal, and then there is a smart check at this point before it draws the 5th card. The game checks, do you have 1 or more basic Pokemon in those first 4 cards? If the answer is yes, you already have 1 or more basic Pokemon, then it draws the 5th card like normal. But if the answer is no, you have 0 basic Pokemon in your first 4 cards, then it draws the 5th card from only your pool of basic Pokemon. So this results in quite a different hand probability. There is a 75% chance in this theory that you have exactly 1 basic Pokemon in your hand. Remember, this is with my deck of exactly 4 basic Pokemon. There's a 21% chance that you have exactly 2 basic Pokemon in your hand. There is a 3% chance that you have exactly 3 basic Pokemon in your hand. And just like before, there is a less than 1% chance that you have all 4 basic Pokemon in your starting hand. The final theory is the forced first rule. This rule means that the first card you draw is only from the pool of basic Pokemon. So you will always have a basic Pokemon drawn first, and then the remaining 4 cards will be drawn at random like normal. And this is going to lead to our highest number of possible Pokemon in your hand. there's only a 47% chance that with your deck of exactly 4 basic Pokemon, you have exactly 1 basic in your starting hand. There is a 43% chance with this theory that you would have exactly 2 basic Pokemon in your starting hand. There is a 9% chance that you would have exactly 3 basic Pokemon in your starting hand, and similar to all the others, less than a 1% chance of having all 4 basic Pokemon in your starting hand. That was a lot of information, so let's look at it here displayed on a table. In Theory 1, the redraw theory, where you redraw your hand if you have no basic Pokemon, there is a 65% chance to have exactly 1 basic, a 30% chance to have 2, a 4% chance to have 3, and a 0.2% to have 4. In the pity rule, where there's that smart check after you draw 4 cards, there is a 75% chance to have 1, a 21% chance to have 2, a 3% to have 3, and a 0.1% to have 4. And in the forced first rule, where the first card you draw is always a basic, there is a 47% chance to have 1, a 43% chance to have 2, a 9% chance to have 3, and a 0.4% chance to have 4. I went into the game and manually ran 250 games and recorded the data with this deck of 4 basic Pokemon to see what the actual numbers are like. And we're going to compare it to these 3 theories to show which one is the way the game developers actually programmed this game. This took me hours and hours to do, so I would really appreciate it if you could like this video and subscribe to the channel for all the work that went into this. All right, let's take a look at the data. Here is the actual data from my 250 in-game tests with a deck containing 4 basic Pokemon. I had 1 basic Pokemon 77.2% of the time. That maps on very closely to the pity rule's 75.1%. It's miles away, about 30% off from Theory 3, and it is 12% off from Theory 1. Now, looking at the 2 basics, I had 21.2% of games where I had exactly 2 basic Pokemon. This maps on almost identically to the pity rule, and again is substantially far away from Theory 3, and is almost 9% away from Theory 1. For 3 basics, this is where it gets interesting. I only had a 1.6% chance of finding 3 basic Pokemon in my opening hand. That's closest to the pity rule, and really, really far away from Theory 3. But it's still almost exactly half of what the pity rule would expect. So that's something to come back to for sure. And finally, with 4 basics, I never, in my 250 tests, drew all 4 basics. That's technically closest to the pity rule's 0.1%, but all of these would have expected me to see it 0 times, so this doesn't actually give us much useful information. So, as we can tell, between 1 and 2 basic Pokemon in your starting hand, the pity rule pretty much exactly explains what we're actually seeing in game. But there's a bit of a discrepancy when it comes to having 3 basic Pokemon in your starting hand. The pity rule would say 3.1%. I only saw 1.6%, which is just over half of what I would expect. Now, this could be due to a number of different things. It could just be that my sample size is 250, which is pretty large, but if I ran 10,000 games, for example, I might see this number being much closer to 3.1%. Or it could be there's something else happening in the game that is making starting hands of high number of basic Pokemon more unlikely. So I went and tested that as well. From our testing, we can see that the pity rule is by far the best of these 3 theories. The only bit of concerning data is this 3.1%, compared to our 1.6% in testing. So we went in to see if something is happening that is preventing you from getting significantly above average number of basic Pokemon in your starting hand. I tested this by increasing my deck from 4 basic Pokemon to 12 basic Pokemon and running an additional 100 tests. These are the expected percentages we would see if the pity rule is correct. And really what I'm paying close attention to here is this 5.11 expected percent to have 5 basic Pokemon in your starting hand. If there is something else at play here where the game is preventing you or reducing the likelihood that you start with a well above average number of basic Pokemon, we should see a substantially lower than 5.11% chance of getting all 5 cards in your starting hand being basic Pokemon. And here are the results from my testing. I actually had a 6% chance, so slightly higher than expected, to have 5 basic Pokemon. All of these numbers are quite close to the expected values that I would see from the pity rule, and this makes me highly confident in 2 things. One, there is not something in play here reducing your likelihood of starting the game with a high number of basic Pokemon. And 2, the pity rule is the system that the game uses to determine your starting hand and forcing you to have at least 1 basic Pokemon. This testing shows that the pity rule, where 4 cards are drawn at random, and then a check is performed to see if you have 1 or more basic Pokemon among those 4 cards. If you do already have a basic Pokemon, the 5th card is drawn at random as well. If you do not yet have a basic Pokemon, the 5th card is drawn from your pool of basic Pokemon only. This rule has been proven to be the way the game draws your starting hand. It far surpassed the other 2 theories in our initial 250 tests, and it was able to beat the concern that we had about potential smoothing or reducing the number of high Pokemon hands when we did the final 100 tests with a 12 basic Pokemon deck. So what does that mean for us? Well, in addition to just simply knowing how the game works, it allows us to do a bunch of further calculations. It lets us talk about the odds and calculate the odds that we are forced to start with a given basic Pokemon. For example, a lot of decks include 1 copy of Darkrai. They don't want to start with Darkrai, but they want Darkrai in their deck. We can now calculate the odds that you will be forced to start with Darkrai. Same with Mega Kangaskhan. It also allows us to calculate the odds of starting with a given trainer card. Prior to this, calculations would be inaccurate because they did not know the way that your initial hand was drawn. And finally, this allows us to calculate how likely we are to find a specific high-value card on your first turn. Say you're playing a Charizard deck. You really want to find that Charmander early. How likely is that? And how can we optimize the deck to increase these likelihoods? These are now questions we can start to ask and answer since we know how your starting hand works. Thank you so much for watching. I hope you enjoyed and that you learned something. Please go ahead and leave a like on the video and subscribe for more informational content. I'll see you in the next one.